The morning of August 7th, 1943, Hillersleben Proving Ground, 60 miles southwest of Berlin. Waffenprüfamt engineer Friedrich Bergmann pressed his stopwatch as the test crew loaded the captured American rifle for what he believed would be a routine evaluation. The olive-drab weapon sitting on the test bench looked deceptively ordinary. Standard wooden stock, iron sights, nothing that suggested revolutionary design. But what happened in the next 90 seconds would force Bergmann to rewrite his entire assessment. The loader, Feldwebel Hans Krüger, a 20-year veteran who had tested everything from Czech machine guns to French mortars, lifted an unusual metal clip from the ammunition crate. 8 rounds of .30 caliber ammunition held together in a U-shaped stamped steel frame. He positioned the clip over the rifle's open receiver and pressed down with a single smooth motion. The bolt snapped forward with mechanical precision. Krüger shouldered the weapon and began firing. 1 round, the spent casing ejected cleanly. 2 rounds, no bolt manipulation needed. 3, 4, 5. Bergmann watched the stopwatch, his expression shifting from professional detachment to something approaching disbelief. 6, 7, 8. The empty clip ejected with a distinctive metallic ping, and the bolt locked open, ready for immediate reload. 12 seconds. 8 aimed shots in 12 seconds. Krüger reached for another clip, inserted it with the same fluid motion, and continued firing. 16 rounds in 24 seconds. Without fumbling, without the manual bolt operation that defined every German service rifle, without the complexity of detachable magazines that plagued their own semi-automatic attempts. Bergmann looked at his colleague, Oberleutnant Werner Schmidt, who had been observing from the firing line. Schmidt, an ordnance specialist who had evaluated the Soviet Tokarev and their own problematic Gewehr 41, spoke first. This changes the mathematics of infantry combat. Every American rifleman carries what we reserve for elite marksmen, but faster. How many of these rifles do the Americans have? The answer, discovered through intelligence reports over the following weeks, was devastating. Not hundreds, not thousands, but millions. By the summer of 1943, American factories were producing over 130,000 M1 Garands per month. Springfield Armory and Winchester had transformed John Garand's 15 years of development work into an industrial avalanche that German arms manufacturers, struggling with resource shortages and competing priorities, could never hope to match. But the true horror for German military planners was not the production numbers, it was the clip system itself. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The roots of this technological mismatch stretched back to fundamentally different philosophies about infantry weapons. In 1919, a young Canadian-born engineer named John Garand had begun working at Springfield Armory in Massachusetts on what would become America's answer to the static warfare of the Great War. His goal was ambitious: create a semi-automatic rifle that could be mass-produced, maintained by average soldiers, and reliable enough to serve as standard issue for an entire army. The U.S. Army Ordnance Department had specific requirements that would shape Garand's design for over a decade. They demanded a fixed, non-protruding magazine. The reasoning seemed sound at the time. Detachable magazines could be easily lost on the battlefield. They protruded awkwardly and complicated manual of arms drills. They were more susceptible to mud and debris. The British had learned hard lessons about lost magazines with the Lee Enfield. The Americans wanted no part of those problems. So Garand, working through the 1920s and early 1930s, developed something entirely different. An en-bloc clip system, a stamped steel clip that held 8 rounds in a staggered formation. The clip itself was inserted into the rifle's fixed internal magazine from the top. When loaded, the bolt automatically closed and chambered the first round. When the 8th round was fired, the empty clip was automatically ejected, and the bolt locked open, signaling immediate readiness for reload. The brilliance lay in the simplicity. A soldier did not need to manipulate individual cartridges under fire. He did not need to carefully insert a detachable magazine that could be damaged or lost. He simply grabbed a preloaded clip from his bandolier, pressed it down into the receiver until it clicked, released pressure, and was immediately ready to fire 8 more rounds. The entire reload sequence took less than 3 seconds with minimal training. German arms development had followed a completely different trajectory. In 1933, when German rearmament officially began under the new regime, ordnance planners faced a choice. They could pursue semi-automatic rifle development, a costly and technologically uncertain path, or they could refine and modernize their existing Mauser bolt-action design, proven through decades of service. They chose refinement. The Karabiner 98K, introduced in 1935, was an evolution of the Gewehr 98 that had served in the Great War: shorter barrel, updated sights, improved metallurgy, but fundamentally the same bolt-action system. 5 rounds loaded via stripper clips, each shot requiring manual operation of the bolt to eject the spent casing and chamber a new round. The decision seemed logical. The Kar 98K was reliable, accurate, and relatively inexpensive. German doctrine emphasized the machine gun as the squad's primary weapon, with riflemen supporting the gun crew. Individual rifle rate of fire mattered less than coordination and fire discipline. Besides, semi-automatic rifles were expensive, complex, and consumed ammunition at rates that seemed impractical for sustained operations. By 1941, as German soldiers encountered Soviet troops carrying semi-automatic Tokarev rifles in increasing numbers, ordnance priorities shifted. Both Mauser and Walther were tasked with developing semi-automatic rifles. The resulting Gewehr 41 designs, one from each manufacturer, entered limited production. But both suffered from critical flaws. The Mauser G41M proved unreliable. The Walther G41W, while more successful, was front-heavy, complex, and featured a fixed 10-round magazine that required loading with 2 5-round stripper clips. Worse, the magazine could not be easily unloaded without firing all rounds. The rifles were expensive to produce and difficult to maintain in field conditions. German engineers studied captured Soviet Tokarevs and noted their simpler gas system. This led to the improved Gewehr 43 in late 1943, which incorporated a detachable 10-round magazine and a more reliable gas operation system inspired by the Soviet design. But by then, the production capacity and industrial infrastructure were too strained. Fewer than 5,000 G43s were manufactured per month at peak production. Most went to snipers and specialized units rather than general infantry. The M1 Garand, sitting on Bergmann's test bench at Hillersleben, represented everything German semi-automatic rifles were not. It was simpler. The gas-operated system used a long-stroke piston that was robust and forgiving of dirt and carbon buildup. It was lighter. At 9.5 pounds fully loaded, it was comparable to the Kar 98K and actually lighter than the G41. Most critically, it was faster to reload. The en-bloc clip system that US Ordnance had demanded as a requirement turned out to be a revolutionary advantage. A German soldier with a Kar 98K could reload 5 rounds in approximately 8 to 10 seconds under ideal conditions, longer under stress. A soldier with a G43 could swap magazines in perhaps 5 seconds, but most G43 users in the field carried only 1 magazine, meaning they had to reload that same magazine with stripper clips between engagements. An American soldier with an M1 Garand could reload 8 rounds in under 3 seconds. The clip was disposable. Preloaded clips were carried in cotton bandoliers that held 6 clips each, 48 rounds ready for instant reload. No fumbling with loose cartridges, no complex magazine insertion, just press, release, fire. The implications extended beyond simple rate of fire. In combat, the psychological advantage proved as significant as the mechanical one. German infantry training from 1939 through 1943 emphasized fire discipline. Careful aim, controlled volleys, conservation of ammunition. These principles worked well when facing opponents with similar weapons. But American infantry doctrine built around the M1 Garand's capabilities, emphasized volume and suppression. Fire and movement. Overwhelming firepower to pin enemy positions while other elements maneuvered. The average American soldier fired more rounds per engagement than his German counterpart, not because of poor discipline, but because his weapon enabled sustained rapid fire without compromising accuracy. The test reports from Hillersleben proved damning when compiled. Bergmann's team conducted exhaustive trials throughout August and September of 1943. They tested reload times, sustained fire rates, accuracy at various ranges, and reliability under adverse conditions. They compared the M1 directly against the Kar 98K, the G41, and early examples of the G43. Rate of fire tests showed the American rifle maintaining 4 to 5 aimed shots per minute over extended periods. The Kar 98K, even with veteran crews, topped out at 2 shots per minute sustained. The G43 could match the M1's rate of fire, but ammunition handling remained slower due to the detachable magazine system when only one magazine was available. The reload time differential proved most striking. Under simulated combat stress, with testers wearing gloves and firing from prone positions, M1 Garand reloads averaged 2.8 seconds. Kar 98K reloads using stripper clips averaged 9.4 seconds. G43 magazine changes averaged 4.7 seconds, but reloading the magazine itself with stripper clips added another 12 seconds. Reliability tests subjected the weapons to mud, sand, and temperature extremes. The M1's gas system proved remarkably tolerant. Even after 500 rounds without cleaning, the weapon continued functioning with only minor stoppages. The G41 jammed repeatedly under similar conditions. The G43 performed better, but still required more frequent maintenance. The ergonomics evaluation noted something subtle but significant. The M1's en-bloc clip loaded from the top, meaning the shooter never had to remove the rifle from his shoulder or lose sight of his target area during reload. The fixed magazine meant no protruding metal to catch on equipment or complicate movement. The automatic bolt lock after the last round provided instant visual and tactile feedback that a reload was needed. By contrast, the G43's detachable magazine required the shooter to look away from the target to insert the magazine properly. The magazine release was less intuitive. The magazine itself, protruding from the bottom of the rifle, was vulnerable to damage from mud or impacts. Bergmann's final report, submitted to the Heereswaffenamt in October 1943, contained a section that would be quietly referenced in German ordnance circles for the remainder of the war. He wrote, "The American M1 rifle represents a fundamental advance in individual infantry firepower. The en-bloc clip system, while initially appearing crude compared to our detachable magazine approach, proves superior in practical application. The clips are lighter, cheaper to manufacture, easier to carry in quantity, and faster to employ under combat conditions. More significantly, the clips are designed as disposable items, eliminating concerns about magazine loss or damage that complicate our own semi-automatic rifle logistics." He continued, "Most concerning is the production scale. American manufacturing capacity has mass-produced this complex weapon to the point where every American rifleman carries one. We have encountered these rifles in growing numbers in North Africa, Sicily, and now Italy. Intelligence suggests the invasion of France will place hundreds of thousands more in enemy hands. Our semi-automatic rifle production cannot approach these numbers, and our standard Kar 98K, while reliable, cannot compete in firepower." The report concluded with a recommendation that was equal parts military analysis and industrial reality. We should prioritize development of simplified semi-automatic rifles suitable for mass production, with particular attention to ammunition handling systems that match or exceed American reload speeds. However, given current production constraints and material shortages, widespread distribution of semi-automatic rifles to general infantry forces appears unattainable before war's end. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The first German soldiers to encounter M1 Garands in combat experienced the weapon's advantages before ordnance evaluators could quantify them in test reports. The initial meetings occurred during Operation Torch, the Allied landings in North Africa in November 1942. American units, many still partially equipped with M1903 Springfield bolt-action rifles, began receiving M1 Garands in increasing numbers as the North African campaign progressed. By the time of the Sicily invasion in July 1943, American infantry was largely equipped with the Garand. German after-action reports from Sicily contain the first widespread mentions of American rifle firepower. A report from the 15th Panzergrenadier Division, engaged near Gela, noted, "American infantry demonstrated unexpected fire discipline and volume. Individual squads maintained sustained fire that would typically require twice their number armed with standard rifles. Enemy riflemen appeared to reload with unusual speed." The mathematics became clearer as more engagements were analysed. A German infantry squad in 1943 typically consisted of 9 men. 5 carried Kar 98K rifles. 1 carried an MP40 submachine gun. 1 served as a machine gunner with an MG34, MG42. 2 served as assistant gunner and ammunition carrier. The 5 riflemen, under ideal conditions, could produce approximately 25 aimed shots per minute combined. An American infantry squad in 1943 consisted of 12 men. 8 carried M1 Garands. 1 carried a Browning automatic rifle. 1 carried an M1 carbine. 2 carried M1911 pistols, or additional carbines. The 8 Garand armed riflemen could produce approximately 240 aimed shots per minute combined, assuming 4 shots per minute per rifleman sustained. But the comparison extended beyond simple round counts. The German squad was built around supporting the machine gun. The MG34 or MG42 provided the primary firepower. Riflemen protected the gun crew, suppressed targets, and provided security. This doctrine worked effectively when facing opponents with similar weapons. Against an American squad where every rifleman possessed semi-automatic firepower, the dynamic shifted fundamentally. American squads could suppress German machine gun positions with concentrated rifle fire alone. 8 Garands firing in coordinated volleys could force a German gun crew to take cover, buying time for other American elements to maneuver. By the time the German riflemen attempted to counter this fire, they were already outgunned nearly 10-1 in terms of practical fire rate. The Italian campaign, beginning with the Salerno landings in September 1943, reinforced these lessons repeatedly. A Gefreiter named Klaus Dietrich, serving with the 16th Panzer Division at Salerno, described a typical engagement in a letter that somehow passed through censors. He wrote, "The Americans advance differently than the British or Russians. They move in short rushes, but when they fire, everyone fires. Not carefully aimed single shots like we were taught, but rapid fire that sounds like machine guns. By the time I work my bolt and aim for a second shot, they have already moved or gone to ground." Dietrich's observation captured a fundamental tactical difference. German infantry doctrine emphasized marksmanship and ammunition conservation. Soldiers were trained to fire single, well-aimed shots at identified targets. This made sense with bolt-action rifles, where each shot required several seconds to prepare. But it left German soldiers exposed during the bolt manipulation time. American doctrine, built around M1 capabilities, emphasized fire superiority. The goal was not necessarily to hit with every shot, but to suppress enemy positions while other elements maneuvered. The semi-automatic action allowed American soldiers to maintain their aim between shots. They could fire, observe the impact, adjust, and fire again without losing their sight picture or target acquisition. The clip system itself became a subject of German analysis and grudging admiration. Oberingenieur Walter Schmidt, an ordnance specialist who examined captured M1 rifles at the Berlin testing facility in late 1943, produced a detailed report on the en-bloc clip mechanism. His assessment, preserved in captured documents now held at the U, S. National Archives, revealed German recognition of American innovation. Schmidt wrote, "The clip system initially appears wasteful. Discarding the steel clip after each use seems inefficient compared to our reusable magazines. However, practical testing reveals significant advantages. The clip weighs only 18 grams. It costs approximately 3 cents American currency to manufacture. A soldier can carry 48 rounds in 6 clips with less weight and bulk than 4 10-round magazines for our G43. He continued, "More critically, the loading procedure is faster and more foolproof than magazine insertion. Under stress, in darkness, or with cold fingers, pressing the clip down into the receiver requires less fine motor control than aligning and seating a detachable magazine. The automatic ejection eliminates one step. The automatic bolt lock provides instant tactile feedback. The American soldier knows his rifle is empty without looking. He knows it is loaded without checking. This is superior design for mass conscript armies." But Schmidt's most damning observation came in his conclusion. "We could replicate this system. The engineering is not complex. However, conversion would require redesigning our rifles from the receiver upward. Manufacturing would demand new tooling, new training, and months of production we do not possess. The Americans designed this system from the beginning. We are attempting to add semi-automatic capability to a bolt-action platform. They built semi-automatic rifles and then optimized the ammunition handling. This is the correct sequence. We have done it backward." The tactical advantages of the en-bloc system became most apparent in sustained engagements. During the fighting around Monte Cassino in early 1944, American infantry repeatedly demonstrated the reload speed advantage. Lieutenant Ernst Weber of the 1st Parachute Division described a typical hillside firefight in a letter to his family that German censors somehow missed. He wrote, "We occupy strong positions on the high ground. By all doctrine, we should dominate the Americans advancing uphill. But their rifles change the equation. They advance by rushes. When they go to ground, they immediately open fire. Not single shots to conserve ammunition, but rapid fire. The sound is continuous. While they shoot, other squads advance. When we attempt to fire back, our bolt-action rifles cannot match their volume. By the time we work our bolts, they have already adjusted their aim." Weber continued, "More frustrating is their reload speed. We train our men to watch for the enemy to reload, then advance during that vulnerable moment. With bolt-action rifles, a man reloading is defenseless for several seconds. But the Americans reload so quickly that by the time we recognize the pause, they are already firing again. Their clips seem to insert instantly. We discussed this among the officers. No one has a tactical solution. We rely increasingly on our machine guns, but the Americans simply concentrate their rifle fire on the gun positions until our crews cannot maintain fire." The Normandy invasion of June 1944 brought the firepower gap to its most decisive manifestation. By D-Day, American infantry divisions were fully equipped with M1 Garands. The German defenders, meanwhile, were increasingly filled out with undertrained coastal defense units, older reservists, and teenagers rushed through abbreviated training. The fighting in the hedgerows demonstrated how the M1's advantages compounded in close-quarters combat. Grenadier Paul Fisher, 19 years old, serving with the 352nd Infantry Division near Saint-Lô, survived the campaign and provided testimony to American interrogators. His account, recorded in July 1944, captured the psychological impact of facing sustained American firepower. Fisher stated, "In training, they told us the Americans were soft, city boys who could not endure hardship. Their weapons were mass-produced trash that would fail under field conditions. Everything was a lie. In the hedgerows, we could not see more than 30 meters. We would hear them coming. Then the shooting would start. Not scattered shots, walls of fire, every man firing as fast as he could pull the trigger. We tried to return fire, but working the bolt exposed us. Every time you moved to chamber a round, 3 Americans were shooting at your position." He continued, "The clips were the worst part psychologically. You could hear them. That metal ping when they ejected, it meant an American had just fired 8 shots and was about to fire 8 more. We listened for that sound constantly, hoping to catch them vulnerable during reload. But the reload was so fast. Maybe 2 seconds. By the time you identified the sound, located the position, and aimed, they were already shooting again. Some of our men became obsessed with listening for the ping. It drove them mad. The Battle of the Bulge in December 1944 provided German forces with one final opportunity to face American infantry on more equal terms. The surprise offensive threw inexperienced American units into desperate defensive battles. But even caught off guard, American soldiers retained their firepower advantage. Private First Class Donald Burgett of the 101st Airborne Division, defending Bastogne with an M1 Garand, described the German attacks in his memoir. They came in waves through the snow. We were surrounded, low on ammunition, cold, but we had our Garands. We fired until the barrels were hot enough to melt snow. The semi-automatic action meant we could keep shooting. If we'd had bolt-action rifles like the Germans, they would have overrun us on the first day. On the German side, Obergefreiter Klaus Hartmann, attacking with the 26th Volksgrenadier Division, experienced the same battle from the opposite perspective. His account, given to a military chaplain after the war, revealed the frustration of attacking American positions. We outnumbered them, we had surprised. We had better positions initially. But we could not break through their lines. Every American position poured out fire like a machine gun nest. We would attack, and 30 rifles would open up simultaneously. Not bolt-action rifles requiring time between shots. Continuous fire that shredded our formations. Hartmann added a detail that appeared in numerous German accounts. Our officers told us to listen for the clip ejection sound and attack when Americans were reloading. We tried, but coordinating an assault based on hearing a small metal sound in the middle of battle was impossible. Artillery, machine guns, mortars, all made more noise than a rifle clip. And even when we heard it, the Americans reloaded, before we could exploit the moment. The tactic existed in theory but failed in practice. By early 1945, as Allied armies pushed into Germany itself, the disparity had become absolute. German infantry units were shadows of their former strength. Ammunition shortages meant many soldiers carried fewer than 20 rounds. Training replacements arrived at the front with minimal instruction. Equipment was worn out, exhausted by years of war. American units, by contrast, were at peak strength and equipment. A standard American rifleman in March 1945 carried his M1 Garand, 80 rounds in 10 clips, grenades, and confidence born from months of successful offensive operations. The industrial base that supplied him never wavered. Ammunition was plentiful. Replacements arrived well-trained and properly equipped. Unteroffizier Heinrich Müller, defending a village near the Rhine in March 1945, made a final observation in his diary entry dated March 14th. He wrote, "Today I discarded my car 98K. I found an American Garand on a destroyed vehicle. I cleaned it, loaded it with clips from a dead American, and used it in combat. I felt like a traitor to everything I was taught about German engineering superiority. But I wanted to survive. The Garand gives me a chance the car 98K does not." Muller's diary entry continued. "My sergeant saw me with the American rifle. He said nothing. I am not the only one. Half our squad now carries captured weapons when we can find them. American rifles, Russian submachine guns, anything that shoots faster than our standard issue. This is what we have become. An army that trusts enemy weapons more than our own." If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The industrial statistics told a story of overwhelming American material superiority. By December 1944, Springfield Armory and Winchester had produced over 4 million M1 Garands. Monthly production remained above 150,000 rifles, even as the European War approached its conclusion. The rifles were built to standardized specifications that allowed parts interchangeability. A broken firing pin could be replaced in minutes with parts carried by unit armourers. German semi-automatic rifle production told a different story. The Gewehr 43, introduced in 1943, never exceeded 10,000 units per month. Total production by war's end was approximately 402,000 rifles. More critically, the G43 was more complex to manufacture, requiring specialized machining and higher-grade steel than Germany could consistently provide by 1944. The cost differential revealed the industrial gap. An M1 Garand cost the U.S. government approximately $85 to produce in 1944. A Kar 98K cost approximately 70 Reichsmarks, roughly $28 at official exchange rates. But a Gewehr 43 cost over 130 Reichsmarks, approximately $52, and required twice the machine hours to produce. More significantly, the M1's en-bloc clips cost approximately 3 cents each to manufacture. The clips were stamped steel, requiring minimal machining. A G43 detachable magazine cost approximately 2 Reichsmarks, roughly 80 cents, and required more complex manufacturing. An American soldier could carry 6 clips for 18 cents total cost. A German soldier carrying 3 spare magazines represented $2.40 in magazines alone. The ammunition consumption rates revealed the philosophical gap. American infantry doctrine in 1944 recommended soldiers carry 80 rounds, 10 clips, for standard operations. In practice, many soldiers carried more. The supply chain supported this. Consumption. Ammunition was plentiful, regularly distributed, and rarely restricted except during the most intense battles. German infantry in 1944 were increasingly restricted to basic ammunition loads due to production and transportation difficulties. A standard load of 60 rounds, 12 5-round stripper clips for the Kar 98K, was often reduced to 40 or even 30 rounds by late 1944. Soldiers were instructed to fire only when certain of hitting the target. Ammunition conservation became as important as marksmanship. The psychological toll of this disparity appeared repeatedly in German soldier accounts. Knowing your enemy could fire 3 times more rounds, reload 3 times faster, and receive unlimited resupply created a sense of inevitable defeat that no amount of tactical training could overcome. The individual German soldier might be brave, well-trained, and determined, but his rifle betrayed him every time he worked that bolt, while American semi-automatic fire continued unabated. The technical evaluations conducted at Hillersleben and other German testing facilities had quantified the problem by mid-1943. The reports sat in filing cabinets at Ordnance headquarters. Engineers understood the disparity. Field commanders reported it repeatedly. But Germany lacked the industrial capacity, the time, and the resources to bridge the gap. Proposals to adopt the en-bloc clip system for German rifles appeared in late 1943. Engineers at Mauser examined the feasibility of redesigning the Kar 98K to accept en-bloc clips. The technical conclusion was clear: possible, but impractical. The receiver would require a complete redesign. Manufacturing would demand new tooling. Production would be interrupted for months. And all this effort would merely bring German bolt-action rifles to American standards of ammunition handling without addressing the fundamental semi-automatic advantage. The G43 represented Germany's best attempt to match American firepower. But even this improved semi-automatic rifle could not match the M1's combination of simplicity, reliability, and ease of use. The detachable magazine system, while theoretically superior to en-bloc clips, proved less practical in combat. Magazines could be damaged, lost, or filled with mud. Loading magazines with stripper clips under fire was slower than simply inserting a fresh en-bloc clip. German soldiers who captured and used M1 Garands invariably commented on the weapon's intuitive design. Feldwebel Ernst Hoffmann, who carried a captured Garand for 2 months in early 1945, wrote in a post-war memoir, "The American rifle fit the hand naturally. The safety was positioned perfectly. The sights were clear. But most impressive was the clip system. Even in darkness, even with gloves, you could feel when the clip was properly seated. the bolt released automatically. You never doubted whether the rifle was loaded and ready. Our G43 required more attention, more thought. The Garand was designed for frightened conscripts to operate under stress. Our rifles were designed for trained soldiers operating calmly. The Americans understood modern war better than we did. By May 1945, as Germany surrendered unconditionally, millions of Kar 98K rifles were stacked in captured arsenals. They were well-made weapons, products of generations of German engineering refinement, but they belonged to an era of warfare that had ended on the fields of Sicily, in the hedgerows of Normandy, and in the forests of the Ardennes. The age of the bolt-action rifle had been superseded by semi-automatic fire and industrial-scale production. The M1 Garand's legacy extended far beyond World War II. The rifle served as the U.S. standard infantry weapon through the Korean War, where it again proved its worth in harsh conditions. The en-bloc clip system, initially controversial among ordnance officials in the 1920s, became recognized as a brilliant solution to the ammunition handling problem. Post-war armies worldwide drew lessons from the M1's success. The Soviet Union accelerated development of semi-automatic and automatic rifles. The British, who had relied on the venerable Lee-Enfield bolt-action rifle throughout World War II, moved quickly to adopt semi-automatic weapons. The newly formed Bundeswehr, West Germany's post-war military, equipped itself with semi-automatic rifles from its inception, explicitly rejecting any return to bolt-action weapons. The technical innovation of the en-bloc clip system influenced subsequent rifle designs, though detachable magazines eventually became standard for military rifles. What remained from Garand's design philosophy was the emphasis on simplicity, reliability, and ease of use under combat conditions. Modern military rifles are designed assuming soldiers will be operating under timidity, extreme stress, in adverse conditions, with minimal time for complex manipulations. The industrial lesson was equally significant. The M1 Garand demonstrated that complex weapons could be mass-produced to high-quality standards when manufacturing processes were properly designed. Over 5 million rifles produced during World War II maintained consistent reliability and parts interchangeability. This achievement required not just engineering brilliance, but industrial systematization that Germany, despite its reputation for engineering excellence, could not match under wartime conditions. General George Patton's famous assessment of the M1 as the greatest battle implement ever devised was not merely patriotic hyperbole. By every practical measure, the rifle had given American infantry a decisive advantage, not in range, not in accuracy, but in the capacity to deliver sustained rapid fire under combat conditions. That advantage, multiplied across millions of rifles and hundreds of thousands of soldiers, had measurably shortened the war. Conservative post-war estimates suggested the M1's firepower advantage had reduced American casualties in infantry engagements by 20 to 30% compared to forces armed with bolt-action rifles. German analysis was starker. A Bundeswehr study in the 1950s concluded that German forces suffered approximately 150,000 additional casualties in the West due to the firepower disadvantage. These were soldiers who might have survived with equal weaponry. The en-bloc clip system, once viewed skeptically by U.S. ordnance officials, had proven to be the key enabling technology. It had allowed John Garand to meet the Army's requirement for a non-protruding fixed magazine, while providing faster reload times than any detachable magazine system of its era. The clips themselves, stamped steel devices costing pennies to produce, had given every American rifleman a reloading advantage measured in seconds, but translated into survival on the battlefield. German ordnance engineer Friedrich Bergmann, who had conducted those initial tests at Hillersleben in August 1943, survived the war and later worked for the Bundeswehr. In a 1968 interview, he reflected on his wartime evaluations of captured American weapons. He was asked specifically about the M1 Garand and its en-bloc clip system. Bergmann responded, "We understood what we were facing by late 1943. The reports were clear. The weapon was superior. The clip system was faster. American soldiers could maintain fire rates we could not match, but understanding a problem and solving it are different matters. We lacked time, materials, and industrial capacity. More fundamentally, we had made critical decisions years earlier that locked us into bolt-action rifles as standard equipment. The Americans had made the opposite decision in the 1930s. By 1943, we were living with the consequences, he continued. The tragedy was not that American engineering was superior. It was that American industrial philosophy was superior. They designed weapons for mass production and mass armies. We designed weapons for craftsmen and professional soldiers. When war became industrial, when armies became measured in millions rather than thousands, our approach failed. The en-bloc clip symbolized this difference. It was disposable, mass-produced, cheap, and brilliantly effective. We would never have designed such a system. We would have insisted on reusable magazines, complex mechanisms, precision manufacturing, and we would have been wrong. The testing facility at Hillersleben, where Bergmann and his colleagues had first quantified the M1's advantages, was abandoned after the war and eventually demolished. The reports documenting German recognition of American firepower superiority were captured by U.S. forces and archived. They remain today as testament to one side's clear-eyed assessment of its technological disadvantage and its inability to overcome that gap. The individual German soldiers who faced M1 armed American infantry learned the lesson more directly. They learned it in Sicily, when American fire forced them from positions they should have held. They learned it in Normandy, when American squads advanced through hedgerows with sustained fire that bolt-action rifles could not answer. They learned it in the Ardennes, when surrounded American units held their ground with rapid semi-automatic fire. And they learned it in Germany itself, when their own soldiers preferred captured American rifles to their standard-issue weapons. The en-bloc clip, that simple stamped steel device holding 8 rounds of .30 caliber ammunition, had been more than an ammunition carrier. It had been a force multiplier. It had transformed the M1 Garand from a good semi-automatic rifle into a weapon system optimized for combat effectiveness, and it had given American infantry a measured, quantifiable, decisive advantage in the firepower that determined infantry engagements. Unteroffizier Heinrich Müller, who had discarded his Kar 98K for a captured Garand in the war's final weeks, survived to see Germany rebuilt. In a 1983 interview, he was asked what he remembered most vividly about combat against American forces. His answer was immediate. The sound of those clips ejecting, that ping. Every time I heard it, I knew an American had just fired 8 shots and would fire 8 more in seconds. We had no answer to that. We worked our bolts as fast as we could, but it was never fast enough. The clip system seemed so simple, so obvious in hindsight. Why had we not thought of it? Why had we not adopted it? Those 8-round clips, loading in seconds, decided more firefights than all our tactical doctrine combined. The M1 Garand had not won World War II alone. Air power, armor, artillery, logistics, and the determination of soldiers from multiple Allied nations had all contributed to victory. But in the fundamental equation of infantry combat, where rifles met rifles and soldiers met soldiers, the M1 and its 8-round en-bloc clips had provided American forces with an advantage that German engineering, despite decades of refinement and reputation for excellence, had never overcome. That advantage had been recognized, quantified, and documented by German engineers and soldiers throughout the war. They had tested captured rifles. They had filed detailed reports. They had proposed solutions. But they had lacked the time, the resources, and the industrial capacity to bridge the gap. By the time German ordnance established that 8-round clips made American rifles faster, more effective, and more deadly, the window for response had already closed. The lesson remained clear for post-war military thinkers. In modern industrial warfare, individual weapon superiority mattered less than the capacity to produce superior weapons in overwhelming quantities. The M1 Garand, with its brilliantly simple en-bloc clip system, had been both a superior weapon and a mass-produced weapon. That combination had proven unstoppable. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.